Okay, we're going to start with section 5.1. Chapter 5 is all about writing linear equations. Very fundamental, very foundational skill. You use it all through calculus and statistics and likely beyond. So here we go. We are going to start by writing linear equations in slope-intercept form. And this is what a linear equation looks like. Y equals mx plus b. That's the most sort of generic fundamental form, where m is the slope and b is what's known as the y-intercept. So if I look at a line, here it goes through the point 0, 2. That is the y-intercept. It's the initial value. It's the value of y when x is 0. So b is 2. And this is showing that slope, is, we often say slope is rise over run. And because of that, we can calculate slope by taking the change in the y values. That's how I find the rise. And putting it over the change in the x values. That's how I find the run. If your scale on your graph is ones, you can just count, and I sort of call that the rookie or junior varsity version. It'll get more complex than that, but it's good to be able to identify that conceptually. It's rise over run. So here's an example, y equals 1/3 x plus 2. That would be the equation for this line, because m, the slope, is 1/3, and the vertical intercept, the starting point, is 2. And just to remind you, what are x and y? X is the input and y is the output. In real life, there's no such thing as x and y. We have things like elevation and temperature, or years and costs, or fat content and calories. We have all kinds of relationships between variables. So here are some of the practice problems you're going to do. It just says write an equation with the given slope and intercept. So basically they're giving you the slope. The slope is 8. So on my paper I would write m equals 8. It's helping me identify those things that I need. And the y-intercept is -7. So b is -7. So my generic equation is y equals mx plus b. I'm looking for a relationship between y and x. My m is 8, and my b is -7. That's the answer. The next couple of examples, so there's, that's anytime you're given the slope and the intercept, that's about as fundamental as it gets. Just plug the slope in, the intercept in, and you have your relationship between the input and the output. So there's going to be a few examples coming up. Now, these are going to be about writing equations given 2 points. And there's a variety of ways you could be given 2 points. You might get the 2 points right from the graph. Here's 0.03, here's 0.4, -2. They might just give you the coordinates, 0, 3, 4, -2. They might give it to you in what's known as function form. So this is a function that when 0 is plugged in, 3 comes out. This isn't multiplication, this is like reading this. This function has a 0 going into it, and then a 3 comes out. And the same function, when 4 goes in, -2 comes out. So literally, this is a point. When you see function form, you should immediately translate it to a point. 0 went in, 3 came out. 4 went in, -2 came out. So they're all essentially the same problem. It's just that the 2 points are given to you in different ways. And for 5.1, all of our points will always, at least one of the points will always be the y-intercept, the place where the line crosses the y-axis, the value of y when x is 0. Notice I have a 0, 3 here. That's my y-intercept. So here's an example where I have a graph, 2 points with the graph. So my equation is y equals mx plus b. From the graph, I can immediately see that my vertical intercept is 1, my y-intercept is 1. Now, I didn't draw these to scale, so you can't just do the rise over the run business. You can sort of look at it. -1 to 1 would be a rise of 2, and 0 to 5 would be a run of 5. So my slope is, well, this is down, right? So -2 over 5. So y equals -2 over 5x plus 1. Now we could have calculated this. So if my 2 points are 0, 1, 5, -1, the first thing I will do, and it doesn't matter which you call point 1 and which you call point 2, as long as x1 goes with y1. And then if I use the slope formula, I can just plug values in. -1, whoops, there's my comma, y2 minus y1 over x2 minus x1. Now you have to be very careful. Label your points and plug them in carefully. If I go -1, 1, I have to go 5 minus 0. You can't go -1, 1 and then 0, 5. You can't switch the order that you do it in. That's why it's important to label, important to write your relationship, and important to plug things in accurately. And you can see if you calculate it, you get the slope. But here's the equation for that line. So again, here's my vertical intercept, so I know my b is -2. And again, I can do the rise over the run. And if I go from -2 to +2, that's a rise of 4. And if I go from 0 to 4, that's a run of 4. So my slope is rise over run. My rise is 4. My run is 4. That's 1. If I do this again, where I label this x1, y1, and that x2, y2, and I plug it in, y2 minus y1, that's my rise. So I'd have 2 minus -2 over 4 minus 0, and I would get 4 over 4, or 1. So either way, you'll have a case where eventually you'll have to use this method. But again, the question is, write an equation for a line. And what do I need for that equation? I need the slope and the vertical intercept. My slope was 1, and my vertical intercept, 1x, plus -2. And you should tidy that up and write 1x minus 2. So here we go. Here we're just given 2 points. And again, because this is 5.1, this is the easiest sort of version. Here's my vertical intercept. See, when x is 0, y is -8. So that immediately tells me that b is -8. And then if I label this x1, y1, and this x2, y2, sorry, it's a little jammed in there, I find my slope, y2 minus y1, so -8 minus 1 over 0 minus a -3. Lots of negatives and keeping track of stuff and being very careful. -8 minus 1 is -9. A 0 minus minus becomes a plus. So overall, I like to always write my slopes as a fraction because it's rise over run. I didn't do that last time. So here was my vertical intercept. Here is my slope. So y equals -3 over 1x minus 8. And the reason I tossed this one at you is because, oh, there's a 0 and there's a 0. Which one is the vertical intercept? Remember, the vertical intercept is the value of y when x is 0. That's where it crosses the graph. If I were to graph this, it'd be 0, -5 would be down there. 7, 0 is somewhere over here. So there's my vertical intercept. That's my b. My b is -5. x1, y1, x2, y2. M equals y2 minus y1. Notice me writing the relationship every time. Why do I do that? So I don't make a mistake. y2, 0, minus y1, -5. x2, 7, minus x1, 0. And this just becomes 5 over 7. So y equals mx plus b, y equals 5/7 x minus 5. Function notation, what did I tell you about function notation? When you see this, 0 went in, 2 came out. 2 went in, 4 came out. So the very first thing I do when I see function notation is immediately write it up as points. And then I'm right back here. I'm at the same problem. So again, x1, y1, x2, y2, and we should recognize that this is my vertical intercept when x is 0, y is 2. So my slope is, if you write it over and over, you won't forget it, 4 minus 2 over 2 minus 0, which is 2 over 2, which is 1, which is 1 over 1. So y equals 1x plus 2. There's my b. So function notation isn't any different, just make sure you write the points down. There's function notation. What are you going to do? Immediately interpret it to point. 0 went in, 9 came out. 3 went in, 0 came out. x1, y1, x2, y2. Which one is my vertical intercept? That's right, this one. b equals 9. Slope is y2 minus y1 over x2 minus x1, which is negative 9 over 3, which is negative 3 over 1. Don't forget the x. Lots of times people forget the x. They'll put in the negative 3 over 1, and then they'll put the plus 9. But the whole idea behind a line is it's an infinite number of coordinates, x, y values, all related by this slope and that vertical intercept. So here's a word problem. These are very straightforward linear functions where we have some rate of change and some initial value. So your family spends $30 for tickets to an aquarium and $3 per hour. There's your rate. So here's your sort of initial value. That's even if you didn't park for any time, you still paid $30. And here's your $3 per hour. That's your slope. So write an equation that gives total cost for visit as a function of hours. So C equals cost, H equals hours. So there's my output, or my Y. Here's my input, or my X. So if I were to write this as Y equals, and this is kind of interesting, like in statistics, they would say I'm starting with 30, and then I'm going to add $3 for every hour. Well, we like to see it like this. In function notation, I would say cost is a function of hours, such that it's $3 for every hour plus 30, the $30 for the tickets. And then if I want to find the cost for 4 hours, I would say the cost of 4 hours, I'm replacing my H with a 4. The cost of 4 hours is 3 times 4 plus 30, which equals 12, plus 30, which equals 42. So the one thing I like about function notation is I know that when it was 4 hours, the cost was $42. So $42 for 4 hours at the aquarium. Okay, so give 5.1 practice a try.